So like I said, the questions range from easy to a little more difficult. Nothing too extreme, but nothing that's real simple either. Right? Let me start it. So quadratic coordinate geometry. We're doing number one first. Number one, very, 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 very basic. So I'll give you like 30 seconds to answer that. What I want you to do though, send me an answer privately, or you can send it to everyone, doesn't matter. But I want you to send me an answer. Remember, this is for you, right? Why I'm doing this is for your benefit. So I need to make sure that you understand what's going on. When you answer a question, send me an answer, please, before I correct it, right? So this is the first one that we're doing. Send me an answer privately, or you can message in the chat. Okay, I have one person send me an answer already. Come on, people, this is for your benefit. I need you to send me your answers. I have two people so far, and two of them have it right. Come on.
I tried to send mine, but I got one sick. I'm not sure.
Wait, what happened when you tried to send it?
Do you mean like on the private chat here or on WhatsApp? Because I tried
No.
to send it on WhatsApp, but I only got one sick.
You could send it here on Zoom.
Okay.
This is the easiest question in this whole thing, eh? You could send me on WhatsApp too, if you want to. You don't have to use Zoom. Okay, so everybody has it right so far. Good job. So I wouldn't go through that one, right? That was the simplest question in this whole thing. So if you get that right, good job. And it's 23 questions, so 22 to go. Second step, no, second question. Where's my laser pointer? They want you to find the gradients of the line that passes through the points 2, 1 and 10, 6. That's also a simple question. So do that for me, send me an answer. I would actually do this question, not this one, but this question, I'll do it. So send your answer, WhatsApp or Zoom. Okay, so we have one person so far. Okay, just to make this a little bit more exciting, the first person to answer. We're going to see who will get the most right. But who would answer first? We're going to see who would get the answer right and who will get it right first. So at the end of the class, I'll tell you who came up with the right answer first, right? So who has the most points? Just to make this a little more competitive, right? Okay, so I have answers already. Okay, and everybody, hold on. Everybody sent me. Yes, okay, nice. I'm not sure if everybody sent me, but all the answers are so far correct. So good job. I need to do this one though, just for people who are watching this recording and didn't understand what happened. Black screen. We know that the equation for gradient is m. Gradient is denoted by m. So if you see m, you know it means gradient. It's y2 minus y1 over x2 minus x1. But you might see the change in your y values over the change in your x values. It means the same thing. What they told us, they said that a line passes through the points 2, 1 and 10, 6. So we did this in class already. Everything, all these questions, everything that I'm going to show you, we did in class already. So if you didn't get it, that means you have to go over something, right? That's the point of this class, to clear up any doubts. So you label which one you want as x1 and y1, x2 and y2. This is how I'm going to label it. This one is my x1 and y1, this is x2 and y2. But remember, it's interchangeable. So if I wanted to, I could have labeled this coordinate x1 and y1, and then this one x2 and y2, right? So just remember that. All I need to do now is substitute the values. y2 is 6, so I put 6 right there, minus y1, that's 1, so I put 1, divided by x2, which is 10, minus x1, which is 2. So that's 5 on 8, and that's why this is the answer. So good job to everybody who sent me that answer. So that's number 2 finished. Do number 3 for me. Send your answer. Italian to see who would be the first person to get it correct, yeah? So try to be the first one. Okay, I have answers already. Nice. They are correct. I just giving you 30 more seconds for this because this one is a simple question as well. All right. So that question was very difficult. Let me show you what the answer is. Actually, let me do this one on the board as well. The general form of a line, of a straight line, is y is equal to mx plus c. And we said that c is the y-intercept. What do I mean by y-intercept? Say I have my y on my x-axis. And I have this line here. You see this point? Wherever the line cuts the y-axis, that's known as my y-intercept. And it has the coordinates 0 and then whatever number it is. Hold on. This is my x value. This is my y value. If you're wondering why x is 0, if you look at this point, hold on, this is my origin, so it has 0, the coordinate 0, 0. Oh. Coordinate 0, 0. On this question, it was y is equal to x plus 5.
Afternoon.
Afternoon. X plus 5. So that means that my gradient, which is m, the coefficient of x in this case is 1. So m is 1. And c is 5. So that means that my y-intercept following this, the coordinate of the y-intercept is 0, comma, and whatever the y value is. So it's 0, 5. Now what I want to show you is why is it like this? Why is it 0, 5? We did all this already, yeah? Why is it 0, 5? So say this is 5, the value of y. Okay, so that answers why 5 is the value of y. But why is x 0? Because look at this. Let me use red. This is the point. This point right here. It lines up with the 5. So the value of 5, that's why y is 5. But if I try to find the value of x, and I draw a vertical line down here, the value of x is 0. And that's why my coordinates is 0, 5, right? We did this already. No worries. What if the gradient was 2? Very good question. So if I had y is equal to 2x plus 5, this c, whatever c is, so y is equal to mx plus c, c is still my intercept. So it still would have been 0, 5. Let me explain why. We did this already, yeah, but let me explain. X, y. We said, say this is the line, so in this case, it would go up like this. It would be a positive gradient. Said this is the y-intercept wherever it cuts the y-axis. And we said in this case, it has the coordinates 0, 5. So what you could say, whenever a line cuts the y-axis or wherever the y-intercept is, the value of x is always 0. See? The value of x is 0, but the value of y is a constant. So what you usually do, so remember, wherever the line cuts the y-axis at the y-intercept, x, the value of x is always 0, just like you see here, the value of x is always 0. So if I wanted to calculate it, this is how you calculate it, yeah? So y is equal to 2. I set the value wherever the line cuts the y-axis, the value of x is 0. So I'll replace, instead of putting x, I'll put 0 here, plus 5. And this would help me to find the y value. But why I said that c is always the y-intercept is because of this. We know any number times 0 is 0, and you have plus 5. And 0 plus 5, that's 5. And that's why the rule is the y-intercept, so wherever the line cuts the y-axis, c is the y-intercept. The value of c is the y-intercept. And this here explains why. At the y-intercept, the value of x is always 0. So if my value of x is 0, I need to find what y is. So when x is 0 equal to 0, what is y? That's what the intercept, that's what the y-intercept means. When x is 0, what is my value of y? And this is how you would work it out. Instead of putting
5.
x, you put 0.
5.
It is 5. Instead of putting x, you put 0. Yeah. 5. But instead of doing all this, the rule states that C is always the y-intercept. But this was just explaining why C is always the y-intercept. Okay. I hope you understand that. Kristen, you understand that, Kristen?
Yes.
Okay.
Yes, miss.
Okay. We did that already, yeah? For people who just came in, these are questions that I put together based on quadratics and coordinate geometry. They range it from easy to a little more difficult. And the aim here is to clear up any doubts about any of the topics. And you should try to be the first person to answer correctly. At the end of the class, I'll tell you who answered the most questions correctly and answer them first. So we did 1, 2, and 3 already. And now we're on to 4. What type of roots does a quadratic 5x squared minus 3x plus 1 equals 0 have? So this is the question you're doing now. First person to answer. You can message me on WhatsApp, message me on Zoom. Doesn't matter. Just first person to answer and answer correctly. Okay, so I have answers already. All right.
Miss.
Mm.
What name again? Standard form.
Repeat the question.
Makes you asking for the never mind.
Okay. So because I already have answers, I'm going to go through it now. So when they say type of roots, when you see this type of roots, you automatically know they're talking about 10 minutes. You'll automatically know they're talking about the discriminant. Type of roots, discriminant. So let me go to discriminant. What is the discriminant and what does it tell me? So discriminant. Not discrimination, discriminant. Right? The discriminant tells me what type of roots the quadratic has. And what I mean by what type of roots, a quadratic might have real roots, so 2 real roots. It could have a real and repeated roots. Real and repeated. Or it could have no real roots. Or some people might say imaginary roots. So I'll just put no real roots. Remember, we did all this already. What does that look like? No. Okay. When they ask the type of roots, we know it could have real roots. So 2 real roots. Let me put the 2. It could have a real and repeated root. repeat. I'll just put, yeah. And it could also have no real roots, or you might see imaginary roots. So what does that look like exactly? We know that a graph, a quadratic graph, is a parabola. And what does a parabola look like? It looks like this. Or you might see this. So y, x, y, this is y-axis, this is x-axis. So a parabola might look like this. It's a curve. Or you might see it like this. This is a minimum curve. A minimum curve looks like a smile. A maximum curve looks like a frown. That's just a little trick to remember it, right? So you might see a parabola, which is the graph of a quadratic function. It looks like this, or it might look like this. When I have two real roots, what you need to recall is that a root, when I say a root of a quadratic function, I mean wherever the parabola, which is this curve, cuts x-axis. What is the x-axis? The x-axis is this horizontal line. This horizontal line I have labeled x, that's the x-axis. And a root is wherever the graph, which is this curve, this blue curve, cuts this x-axis. So in this case, my roots would be here and here, or it would be here and here, wherever the graph cuts the x-axis. And that's an example of what two real roots might look like. But quadratic graphs, they don't always look like that. That's only the case where it has two real roots. A quadratic graph might also have real and repeated roots. And this is what it looks like. Y-axis, x-axis. So I'll just draw a minimum graph right here. This, you could see that it only touches the x-axis once. And that's what real and repeated roots look like. Remember, we did this already, so I won't go into detail. If you need to review it, Google Classroom, right? So this is what real and repeated roots would look like. And if they said it has no real roots, okay, that means that the graph does not touch the x-axis at all. So the graph might look like this. Does not touch this x-axis at all. And that's what it means by having, if I said a quadratic function has no real roots, this is what it might look like. It does not touch this x-axis at all. That's what the discriminant tells us. The discriminant tells us if the quadratic function has two real roots, has real and repeated roots, or has no real roots. In this question, they asked us about the type of roots. They wanted us to identify the type of roots for this quadratic function. The discriminant, there's a formula. So I'll put capital D for discriminant is equal to b squared minus 4ac. This is the quadratic that they gave us, 5x squared minus 3x plus 1 is equal to 0. So if I wanted to find the type of roots, we see type of roots, you know, one time they're talking about discriminant. And I could have two real roots, real and repeated roots, or no real roots. And I would have to use this formula to find it out, to find out what type of roots I have. So A, in this case, is 5. B is minus 3. C is equal to 1. To find the discriminant, all I have to do is substitute the values. So b squared, so that's minus 3 squared, minus 4AC. That's 9 minus 20. One time, you could tell that this is going to be a negative number, right? Negative 11. And like I said, we did this already. So just going to, yeah. Whenever the discriminant is negative, a negative number, that means I have no real roots. So this would be the answer in this case. They want the type of roots. The type of roots, it has no real roots. So this graph, the parabola, will not touch the x-axis, right? When my discriminant is positive, that means it has 2 real roots. And if it's 0, if I plugged in all these values and the answer I got was 0, that means it had real and repeated roots. Like I said, if you need to review that, Google Classroom, right? Do number 5 for me, please. First person to answer. The meter is gonna end, so rejoin after this.